Good morning, everybody. This is Mr. Buff. Nice to see you again. Today we're going to talk about diesel engines. We're going to talk about one of the most popular engines ever made, one of the most best engines ever made, and we're going to learn a little bit about the history of the diesel engine and a little bit about the internal combustion chambers and the different kind of operation of the cylinders in the engine. So pay attention and learn a little bit about the diesel engine. And when we meet during our Zoom meeting, I'm going to ask you a couple questions about the history and some of the operation of the diesel engine. Diesel engines are known to be durable, fuel efficient, high torque producing engines. They're known to be made for big, heavy trucks because they produce a lot of high torque, which means they have a lot of twisting force, which means that they can pull heavy loads. They're also made and designed for fuel efficiency and also to be able to be durable and last a very long time. Diesel-powered vehicles and machines are a vital part of today's world. You'll see them in heavy trucks. You'll see them in heavy equipment. You'll see them in all different kinds of equipment that's used in today's world. So they're a very important part of our economy. They're a very important part of our world. Diesel engines are found in most commercial vehicles. They're used in locomotives, marine vessels, electric generators. You'll see them in big boats, cruise liners. And again, they're made because they're more durable. They've started using diesel engines now, not just for trucks and for heavy equipment, but they also use them now for small, medium-sized automobiles. And they're very popular in Europe. They've been used a lot because their fuel economy is very good as compared to the fuel economy in a gasoline-powered vehicle, and not simply just because the more miles per gallon, but because of the efficiency per gallon. So you can get a lot more power and a lot of efficiency out of a gallon of diesel fuel out of a diesel engine as compared to a gasoline engine. The diesel engine was developed over 100 years ago. And it's made by fuel being burned in a sealed chamber, and the energy is converted to a mechanical energy. So it's an up and down motion changed to a rotary motion, as we'll talk about later. Fuel can be ignited either with a spark or heat of compression. And that's, again, we're going to talk about that a little later, because today's gasoline engines, the cars that most of your parents operate, have a spark plug. And I know a lot of people hear the word spark plug and they think of a gasoline engine, and that's how the fuel is ignited. Okay, fuel systems are ignited with either a spark plug or with the heat of compression. And I'm going to show you the two different ways that's operated. The development of the diesel engine started back in 1861. First man was Nicholas Otto. He developed a 4-stroke diesel engine, and we're going to talk about what the 4 strokes are. Okay, so you can get a little jump on learning about diesel engines and how they operate. In a diesel engine, it uses 2 rotations of what's called the crankshaft in the engine to complete one operating cycle. These 4 strokes are called intake, compression, power, and exhaust, and we're going to talk about those in depth at the end of this slide. The second person to come out with the diesel engine, his name was Rudolf Diesel. Rudolf Diesel's engine, he designed it in 1892, and it later would be called the compression ignition system, or compression ignition combustion system. And that means that the ignition happens in the cylinder without the use of a spark plug, which means there is no spark. And that's the most amazing thing about the diesel engine, is that it operates without any kind of spark inside of the engine. If you're looking at this picture and this is the inside of one of the cylinders of the engine, you'll notice that what happens is there's a explosion inside the engine. The explosion is what makes the power. It's very simply put, inside of this cylinder, if there's a fuel injected into this cylinder and it's a sealed cylinder, when there's a spark, it will make that combust inside the engine. it will make the fuel and the air inside the engine combust and explode and push the piston down, which actually makes your engine turn, and in turn it works to make the wheels turn and make the vehicle go. Now, if you're using a diesel engine, a diesel does not have a spark plug. What happens is the heat of the compression, because there is so much going on in this cylinder, and because of such a high compression ratio, because it's a bigger engine in the way they're designed, when this piston moves up, it squeezes the fuel to such a high temperature, over 4,000 degrees, that the fuel air mixture actually explodes on its own. You can't hear the explosions because they are controlled explosions inside of the engine, and your exhaust system on the vehicle dampens out most of those sounds. If you took off your exhaust system, your engine would sound really, really loud. So I'm going to show you, talk more about and show you pictures more of how the four-stroke engine operates and how it does its job. Rudolf Diesel came up with the idea that when air is compressed by moving a piston up and down in a sealed chamber and heats air up to 1,000 degrees, it's more than hot enough to ignite fuel. The ignited fuel air mixture expands and it forces the piston down on one stroke, which is called the power stroke. That reciprocating motion of the piston makes the piston move up and down, and it actually turns the crankshaft and turns that reciprocating motion into a linear motion, and then the wheels move. There is valves that open and close that allow air out and exhaust out, and it also allows air in and exhaust out. Initially, it was developed to use coal dust for fuel and for locomotives. Later, they were using peanut oil before diesel fuel was settled on. Fuel injection systems are developed to inject fuel at a high compression and must overcome high compression pressures. Fuel injection means the fuel is injected directly into the cylinder. The early diesel engines were large, heavy, slow-speed engines, and they were used for stationary applications, which means they usually just sat in one area, and they were used either to operate another type of machine in the industrial age. They were used for boats. They were more practical at the time because they were very, very large and cumbersome. In 1920s, a man named Robert Bosch started developing practical fuel injection systems, and they were able to be used with smaller, lighter engines. A man named Plessy Cummins produced a diesel-powered car in 1929, and other manufacturers of cars and trucks produced diesel powers. In fact, today you will hear the name Robert Bosch in many fuel injection systems that are still used, and you can hear, I'm sure a lot of you have heard of Cummins diesel engines, and believe it or not, they were invented all the way back in the 1900s. Diesel engines became popular because of their fuel efficiency, which was important around the time of the Great Depression. Fuel savings were great back then, so it offsetted the higher price of the diesel engine. Today, there's many different manufacturers of diesel engines: Caterpillar, Cummins, Isuzu, Kubota, Detroit Diesel. There's many different kinds of engines out there. Most popular names have been around for a long, long time, and they're very durable, long-lasting engines. A typical car engine made today has a life of around 150 to 200,000 miles. A typical truck with a Caterpillar, Cummins, or other diesel engine can usually range in the 500 to 750,000 mile range before they can be rebuilt. And the difference between them, the diesel and the gas, is they can be rebuilt a lot easier. So I've seen a lot of big diesel engines that have rebuilt 2 or 3 times and have over 3 and 4 million miles on them. The advantages of diesel engines are they're efficient. Diesel engine creates a higher compression ratio, which extracts more energy from the fuel. Fuel can be directed right into the cylinder itself. Compression ratio. Simply put, it is the ratio of how much fuel can get squeezed in an area. According to this slide, it shows you this area from where the piston goes up and down, and the area side to side is your piston displacement. So how much fuel and air is injected in there and is squeezed is what's called your compression ratio. The bigger the ratio, the more air and fuel that can be squeezed. In a car vehicle, in a car engine, an automobile gasoline engine, the normal compression ratio is 8 to 10 or 10 to 1. And in a big diesel engine, the difference is 16 to 1. So that means you can compress a lot of air in that cylinder. You can get a lot of fuel in there and you can get a lot of air in there. When it's mixed and it's heated, then you've got a lot of room for that explosion that's going to make your engine run. So the three things you need for an engine to run, which are very important, are fuel, air, and some kind of combustion. Either spark or combustion from the heat of combustion, which is the way the diesel engine operates. So again, those three important things: air, fuel, and some type of spark or ignition. Again, the advantages of diesel engines: diesel fuel also has a 10 to 12% higher energy output. So it can actually give you more bang for the buck. So the more efficient and the more work it does, that means the better that you can, the engine will run, and the more efficient it will be, and the stronger the engine will be. Diesel engines are very diesel. Diesel engines will generally last 3 to 5 times longer than spark ignition engines. As you see in cars, they call them spark ignition engines. Many will operate for over 1,000 kilometers before needing a major overhaul. Okay, more than a million miles or more I've seen on these diesel engines. All right, durability. Very durable because the cylinder walls, the cylinder itself where all the parts are housed, are made very strong as compared to a gasoline engine. There's less maintenance required because there is no spark, and the higher durability adds the higher resale value. Diesel engines do have a widespread use in transportation, construction, mining, electric power generation. They're used on boats. They're used in hospitals. They're used in big power plants. They're used in case the power goes out in a big hospital. Then normally they will have a couple of backup engines sitting there to operate to run the electricity for that hospital. So diesel engines are very popular because they're very durable and used in times when they're really needed. They're usually the primary engines used in heavy duty and commercial vehicles because they produce more power while using less fuel. And they also last longer than other types of engines. Modern diesel engines are becoming more popular in automobiles. There is right now about 12 automobile manufacturers and light truck manufacturers that are using diesel engines. They're using diesel engines because they are actually the most efficient combustion system made as compared to a spark ignition engine in a gasoline engine. Again, back to Rudolf Diesel, he developed the concept of the combustion system. In this engine, heat is produced from compressing air. Let's talk about combustion. We're going to talk about the diesel engine now, actually how it really operates. Okay, engines burn fuel and oxygen. This is a chemical reaction, creates heat and pressure. That's where, especially in a diesel engine, where the power comes and where it all happens, is the chemical reaction from the fuel and oxygen burning. To create a reaction, 3 elements are needed: fuel, oxygen, and heat. And we talked about that earlier. The 3 things needed for a combustion engine to run are fuel, oxygen or air, and heat or spark or combustion, a type of ignition source. Heat is the primary ignition source to start the diesel engine. On a gasoline engine, again, the primary ignition source is a spark ignition, which you need a spark plug for each cylinder. That's the big difference between a diesel engine and a gasoline engine. There are combustion fundamentals. There is a piston. There's one cylinder in an engine. And as you can see, there's the piston. These are called valves. Okay, one is made to let air in and one is made to let exhaust out. There's always some unburned fuels that have to be removed. And that's where your exhaust system comes in. These valves move up and down to either let the air in or out or to let the exhaust out. Okay, the exhaust isn't really only a one-way valve. It only lets it out. The intake lets it in and out. The heat is built up in this area as the piston moves up and down, and the fuel is introduced through a fuel injector. And the force of the combustion from the explosion in this area, in this combustion area, pushes the piston down. And in a normal diesel engine, there are 6 cylinders, which means there are 6 of these pistons in a row, and they all operate at different times. They move it at a different location because when one may be down the bottom, getting rid of the exhaust, the other piston is going up, getting ready to start the combustion cycle. Here is the spark ignition system, and here's how it works in a car. It basically is the same as a diesel engine, except it does not have, you get rid of the spark plug and you have a diesel engine. There's the picture of the engine there, of the engine 1 cylinder, where the air fuel mixture comes in, and it actually is ignited in the second phase, and then it goes through the whole system again. This is normal combustion. This is a spark ignition system. You'll see in just about every car. You'll see here's the normal components are the piston, the intake valve, and the exhaust valve, and the spark plug. All right, keep that in mind because I'm going to explain to you because they both work the same. But in a diesel engine, I want to show you a little bit more in depth of how it works. Here is the compression ignition system. Okay, this is in the diesel engine right here. Okay, as you can see, very similar, diesel and spark. You have a piston, you have a connecting rod, which connects it to what's called a crankshaft, which spins and turns to make the piston go up and down. You have the spark plug in the spark plug engine. You do have you have valves. Usually they're sitting a little different position in a spark or gasoline engine than they are in a diesel engine. As you can see, everything is flat, but they are very similar. The diesel engine and the spark combustion engine are very similar, except for the components and some design. There's our 4-stroke engine. We're going to talk about these 4 strokes, and I want you to remember this: intake, compression, combustion, and exhaust. And we can say it two different ways. If I would tell you right now, and maybe when time comes for our Zoom meeting, I'll quiz you and see if you can remember the intake, compression, combustion, and exhaust. These are the 4 things that have to happen for the engine to run. And in a 6-cylinder engine, this happens at 6 times all at once. Each cylinder is doing a different thing. But we're just taking 1 cylinder right now and looking at what happens at that 1 cylinder. First, you got to remember that this crankshaft is going to go around twice. So that piston is going to go up and down twice to make one 4-stroke cycle. That 4-stroke cycle, you can say intake, compression, combustion, exhaust, or an easier way to remember it is, which my students remember a lot easier, is suck, squeeze, bang, and blow. And here's how we'll explain that to you. As you can see with the cylinder here, these basic components are our crankshaft, our connecting rod, which connects it to our piston. Here is our cylinder block. And remember, we talked about our 2 little valves that open and close. As you can see in our intake stroke, what happens is air comes in and it's introduced into the cylinder on that intake stroke. And that's why they say intake, because the piston comes down and it brings just air, all air. Here's the intake valve, there's our exhaust valve. The exhaust valve is closed because we don't want anything going out. We want just air coming in. Piston's starting to come down, it's bringing in air. Either they also call this stroke the suck stroke because it sucks in air. Okay, as we do that, the piston's coming down. Okay, as we start that's this stroke into our next stroke, what happens is we call this stroke the compression stroke or the squeeze stroke. What happens now is the air that is in this cylinder, simply just air, oxygen. Remember we were talking about the three things we need? This is where the oxygen is squeezed. Okay, the piston's going up and it's squeezing it. There's a big displacement of air that's getting squeezed. And what's happening with the air is it's getting hot and it's building up pressure. The higher the pressure, the more heat, the better efficiency you'll have when you have that fuel injected. Because at a certain time, when this piston is right up the top, which they call top dead center on our compression or our squeeze stroke, what happens is the fuel is injected, and what happens is the heat from the compression makes the cylinder ignite, and we move into our combustion stroke. And as you can see, these valves are both closed because we need a cylinder that's completely tight, completely solid. That's what gives us our good combustion. Like I said earlier, these diesel engines can get up to 4,000 degrees inside that cylinder. And that's what happens is spontaneous combustion, which means there is no ignition. There is nothing to start that explosion. It starts simply by the heat of compression. So as the piston, at that moment, when we go to our combustion, remember we did our intake compression and we did the suck or squeeze, and now we're going to go to the bang section or combustion. And what happens is as soon as that fuel is ignited and that heat is built up, there's an explosion inside the cylinder, and the explosion pressure pushes the piston down. As the piston goes down, it is extreme pressure and extreme force, and it makes the crankshaft rotate, and that's what gives you your power. Out of all 4 strokes, you only have 1 power stroke, and that is this one. That's why they call it the combustion stroke or the power stroke. Suck, squeeze, bang, and now we're going to go to our last stroke. As what happens is, as the piston is forced down, one valve opens, our exhaust valve. And the piston, because of the force, there is such force on our combustion cycle with this crankshaft moving it down, the inertia makes it come back around and it's bringing the piston back up. And the piston then will push out the old spent exhaust gases, whatever is left, and cleans out the cylinder. After that happens, if we could continue on with more pictures, it'll go right back into another phase where it's going to pull, as soon as it comes up and pushes this exhaust, the bad exhaust gases out, it's going to let more air. The intake will open back up, the exhaust will close, and it will start the whole cycle over again. And you remember that this is, if it is a 6-cylinder engine, which most diesel engines are today, it will happen, this will be happening in 5 other cylinders also. And they're all timed in sequence. And that's how the engine runs, because it's timed in sequence, where one cylinder is on its intake stroke, the 6th cylinder will be on its exhaust stroke. But they're designed so efficiently and so perfectly that you don't even notice any differences in fluctuations because of each cylinder going on different strokes. They're operating at unbelievable speeds. The revolutions per hour of some of these vehicles can go up to 3,000 and 4,000 revolutions per minute, which means this crankshaft will go around 4,000 times in 1 minute. That's very fast. It's very, very, very amazing the way these diesel engines can operate. So this is how your 4-stroke cycle engine works. And again, if you had a 4-cylinder engine, which they do make, there's 4-cylinder diesel engines in cars, there's 6-cylinder diesel engines, there's also 8-cylinder diesel engines, which you don't see very often today because the 4-cylinder engines are pretty efficient. They only have 4 cylinders. Instead of having 6, they have 4, but they do exactly the same thing. And again, if we change this 4-stroke cycle engine and just got rid of the fuel injector and put a spark plug in there, you can look at it the same as that's a gas engine. So a gasoline engine works on the same principles. There's just a little bit of a difference when it comes to mostly the ignition. So to review, the 4 strokes of a compression engine is intake, compression, power or combustion, and exhaust. Or if you want to remember it easier, suck, squeeze, bang, and blow. This is really one of the most basic things to learn, but one of the most important things to learn, because my students need to know about this, how these strokes operate, because you can't start working on these engines or working on learning about anything else until you know these basic components and what happens in that engine when it's operating, and what would happen if there was a problem with one of the valves. Let's take, for example, if an intake valve wasn't opening, no air would come in, so naturally there wouldn't be any combustion because there's no air. If our exhaust valve was broken and it wasn't getting rid of the exhaust, or it wasn't letting the cylinder seal, you would have a problem because you couldn't get combustion. So it's a very very important to know that about the 4-stroke cycles. Last year when we did our Summer Explorers, our students actually drew a picture of this to know where the piston is at the time, at what stroke, the intake stroke, and so on. So when we get to our Zoom meeting, I think we're going to talk a little bit about the 4-stroke, and I'm going to ask a couple questions about, you know, what would happen, where are our valves when the intake valve is, when it's during the intake stroke. As you can see, the intake valve is open. Where's our exhaust valve? Exhaust valve is closed. So I'd like you to study this a little bit and look at these pictures, see if you can remember. See if you can remember intake, compression, power, and exhaust, or intake, compression, combustion, exhaust. Remember these cycles because they're very important. And this is the start of how you would learn if you were learning to work on either automotive engines, diesel engines. If you want to look at like motorcycles, motorcycles actually have a 2-stroke engine, which is completely different. It only has 2 strokes, just means 2 of these are gone. The piston only goes up and down 1 time. There's a whole different design. It's there in your lawnmowers and things like that. They use 2-stroke engines, but today diesel engines are very popular, and they're used for all different kinds of applications, as we talked about earlier. And when we come to our Zoom meeting, I want to ask you a couple questions about where some of the applications are for diesel engines, and why they're so important, and why they're needed, and they're so important to us for the way goods are transported and things like that. So I thank you for joining me in this video on learning about a little bit about diesel engines, and I look forward to seeing you at your Zoom meeting. Thank you very much.